we want to talk about how we scaled up MBSE at Digital Rail for Germany and how we bring railway digitalization to a new level. I will begin with a short introduction what we do at Digital Rail for Germany. Then we will look into MBSE and how we apply it here, and we'll move to our main topic for today, our challenges and solutions for scaling up MBSE. We will look into co-working on models across teams and organizations, also how we can make models useful for the general engineering crowd, and at the end we will get some insights into a training mode and hands-on experience for project teams. Let me start with the introduction. You might know that in Germany we have the political goal to double passenger numbers in long-distance transport by 2030. To achieve that, we must increase railway capacity, and we believe that the biggest lever for that is the digitalization of the railway system. We have splitted the railway digitalization in two different stages. The first stage focuses on digitalization that can be rolled out in a shorter term. The advanced digitalization is still in development and consists of fully automated driving, advanced digital infrastructure, as well as intelligent planning and dispatching. Right now, we have more of a classic relationship between the client and Deutsche Bahn, but we want to change that and in the future go into development partnerships and have open platforms. Also, right now, we have a variety of grown systems, interfaces, and rules, and our target is to have a clearly structured system architecture where the system can be automated and simulated and is modularized and standardized. To get to the target, which is a quite complex task, we have adopted MBSE, and I'm handing over to Viktor to give us more insights into that.
Right. So let's have a look at how we use MBSE at DSD. First of all, we use it to create common understanding of the railway domain, our operational processes and needs. Domain is huge. There are many things in it, and we're also not alone. We work a lot with our European partners and especially Europe Rail Joint Undertaking to ensure that whatever we do is interoperable. We also use MBSE to analyze the needs and specify our systems in like real life ground projects to create architectures and use those architectural products in specification work and integration work. And of course, MBSE is really helpful when it comes to validation of our specifications and designs, and we use it next to simulation and prototyping. When it comes to challenges, special challenges for scaling up MBSE, for us, it's mainly about the fact that we're launching many projects in parallel. We're running many projects in parallel and starting projects and boarding teams, getting them to understand the tools, understand the methods. That's quite a challenge, especially when you need to do this same time at scale. But at the same time, also enabling collaboration on models across different teams, across different organizations. That's not so easy when it comes to organizational borders. And finally, making this content, the MBSE product itself, useful for wider engineering audience, for wider crowds. That's also not so easy, but I guess the majority of you know about it already. And so let's have a look at how we solve the co-working challenge. Moritz.
Exactly. For collaboration, we need better ways of co-working on models. And for that, we need to first of all understand where we come from and how our environment looked a few years ago. We had Capella and Jupyter for automation installed on many local devices. All of those devices connected to Team for Capella in order to work together. That had several disadvantages. First of all, everybody had to install Capella locally. We had quite a different set of drop-ins and dependencies. Logs were not collected centrally. We couldn't roll out updates automatically. And working together was also rather complicated via screen sharing. So we built a custom solution to overcome those issues and to find a proper solution for it. And the solution is a centrally managed platform that runs completely in a browser. So everything that you see here in the video is completely running in a browser. and that's crucial for us because we noticed that in many modern projects, we work together across teams and organizations. To name one example, in Europe's Rail, we work together with more than 30 companies. So it's crucial that external partners don't have to install any additional software. All they need to do is to see the website and to be registered. Let me start with a central concept of the Collaboration Manager, and that is projects. I will now go into the coffee machine project, and we noticed that usually we have a group of project members working together on a set of models. Those can be supersystem models, subsystem models, test and integration models, as well as model libraries. A project is a space where all that is grouped together, and we have different project members with different roles. For example, we could have a project administrator who can manage the project and is also able to add and delete users from the project. Also, we have normal project users who either have read and write permission or just read-only permission without the risk to modify the model. But now let's get started and look into Capella itself. So as you can see, we do not only support Capella, but every other tool that runs graphically or as web native tool on Linux. I've now started a Capella session, and I'm now seeing Capella in a browser. And while Capella is starting up, we have to wait a few seconds. But once it is started up, we can already see that there is a model, the coffee machine model, in my personal workspace. And the reason for that is that we have for each user a persistent workspace, which is also persisted across sessions. But now let's look into the Team for Capella connection and connect to a repository. In the drop-down menu, I can only see the relevant repositories for me as users, the repositories I have access to. For authentication against Team for Capella, we have implemented session tokens to improve security in Capella operations. With the token, we can connect to the repository, and once the repository is loaded, I will open a diagram in the model that already exists. I can now work with Team for Capella, for example, create an operational entity. But when it comes to Team for Capella project, we noticed that usually we either work individually, but often also in a group of people. And since many of us work remotely, a good co-working method and a good way of communication is crucial for us. Usually the editor role also changes frequently. So when you imagine you have Teams open and share the screen, you have to switch that over and over again. So we came up with a custom solution for that, and that is called session sharing. So I will now go back into my session overview and go into a split view. On the left side, you can see the admin user. On the right side, you can see the screen of test user 2. The admin user will now share the session with test user 2. And after a few seconds, we will see it popping up on the right screen as well. I will now connect both users to the same session. In Capella, we can see that if I move around the cursor as admin, it also moves around the cursor for test user 2. I can also drag around elements, and that is synced live to test user 2. I can also do modifications to models, and that works as well. Now let's imagine we are in a discussion process and test user 2 has its own proposal. So test user 2 takes over and is now the main actor, and can also do changes to the model, which are synced to the admin user. Now, after we've done changes to the model, we want to terminate our session in order to free up resources on the server and to release the Team for Capella license. If we don't terminate the session manually, we also have a garbage collector that detects inactive sessions and will terminate them after 90 minutes of inactivity. After session termination, we are asked for feedback to provide our engineering toolchain team some insights into the way we are working so that they can continuously improve the platform. So that's how a typical workflow of co-working looks like in the Capella Collaboration Manager. Now let's switch the role slightly and have a look at how we as admins can manage the Capella Collaboration Manager with the focus to Team for Capella in sessions. Team for Capella is a commercial product by Obeo and requires licenses. So we want to make it transparent to users how many licenses are in use. Right now you can see that we have enough licenses available, so we do not expect any license issues in the session. But in the background, I will now add a few more users to the server, and we can see that now most of the licenses are in use, and the user is reminded to terminate the session after use. If I add even more users, then all licenses are in use, and the user is warned that there is no license left and the user should come back later. But we also have a central dashboard for admins to see how many licenses are in use over time to better allocate traffic. And we have the same for sessions, where we can actually also filter for specific sessions to get deeper insights into how users work with sessions. Also, we collect information about the session inactivity for the garbage cleaner in order to terminate sessions after inactivity. Also, we collect logs centrally for users. For example, we can filter for a username and get the logs of all sessions for that specific user. Here, for example, we can see the Capella logs of the user admin, which helps us to investigate issues and bugs more easily. Now I'm back in the front end of the Capella Collaboration Manager and will look into the Team for Capella server management capabilities. You can add any existing Team for Capella server to the Collaboration Manager. When I go to a specific server, we can see the repository management capabilities. For example, I can add a repository, stop the repository, start the repository, or delete the repository from a UI. For existing repositories, I can see in which projects they are in use. For example, the coffee machine model is used by the coffee machine project, and we can also see that a Git repository is assigned to it. We can use the T4C repository and Git repository to set up a pipeline that synchronizes Team for Capella commits to Git commits. Also, we have a documentation for different audience groups. For example, documentation for users, API users, system administrators, and developers. Let's have a look at the user documentation. For example, we have a page where we compare a local Capella installation with the Collaboration Manager. You might want to have a look at that later on. But we also cover typical workflows of users. For example, when it comes to working with Git or Team for Capella.
Yeah, and now let's have a look at how do we make models useful for the wider audience, or for the general crowd. But first of all, why are they not as useful as they should be? As we start to approach wider engineering crowds in our projects, we frequently see that non-MBSE experts find it hard to work with MBSE models, so make use of those because the tools are not intuitive or it's time-consuming, and I could do the same with PowerPoint. Maybe you heard that too. Another reason that we frequently hear is documents and not models are seen as the real-life deliverables. And those stakeholders prefer familiar formats like Word, PDF, Confluence, even Polarion causes some resistance in these user groups. Then teams align around multiplayer tools like Confluence, Polarion, or even SharePoint, because it's easy for them to see each other and what they do and how that results in paperwork changes. And finally, yeah, most of the modern MBSE tools, they are a bit difficult when it comes to automation of production of derived material. So let's say they're not so CI/CD friendly. So how do we fix that? First of all, we try to engage our users in, well, basically where they work. So we don't ask them to go into Capella, I mean, the wider audience, but we actually bring the products of work from Capella into the environment, into GitLab, into Confluence, into Polarion. We also let them provide feedback right there through commenting features in those tools. And modeling teams would use those comments to improve the models. And one important thing is that we continuously update all derived products on all those platforms. So the end users could see the change in near real time, let's say. Yeah, but while changing everything, we also need to keep change control and quality management community happy, and I think we somehow got there. Finally, this amount of feedback from the wider audience, so not just from the architects and MBSE experts, but also from the end users, gives us really good ideas how to improve the collection of good by default templates for generation of those derived products. That makes it easier for us to give the new projects head start. But that was the theory. Let's see how we do this in practice. First of all, we start with rapid prototyping, and for every new model-derived product, we use, in most cases, py-capellambse and JupyterLab for prototyping those things really quick. py-capellambse is optimized for headless performance. It doesn't require any Eclipse or Java. It just runs in a Docker container or, well, anywhere you have Python. Then we have Model Explorer. It's a lightweight web app that provides instant access to on-the-fly generated documents from a Capella model. So you basically can explore your model as if it was a collection of documents, interlinked, of course. And finally, when it comes to formal work, we rely on Polarion, and we synchronize Capella model elements, and not only with Polarion in a fully automated way using CI/CD practices. We also used to do synchronization with Confluence, and we still do it, but it's not in scope of this presentation because it's pretty trivial, and Confluence has a really nice REST API that makes it pretty trivial. Right, so yeah, let's have a look at the Model Explorer. So what you see here are cards, and each card represents a document type. Some documents, you see they are many for model elements, and some documents are singular. And you also see that we're rendering this for in-flight entertainment system. So let's try to see what the system is for by checking out that system definition document. This is also a template here. And this template basically tells the engine how to query the model. All the text, all the content you see here comes from the model itself. And you see quite a bit of red text that helps us to hint the modeling team that they have some work to do to make the template happy. And now we can scroll to system boundary definition, and you see this context diagram here of our system of interest, and it's actually auto-generated. You also notice that aircraft and passenger are dashed. That is a hint for the modeling team that those interfaces are implicit, not explicitly defined. So there are functional interactions between those sectors or with the sectors, but they're not really formalized. You can also scroll down to sections where we talk about functions of the system of interest. And you see we clear in plain text write about the inputs and outputs, where the inputs should come from, where the outputs go, who will consume those outputs, and in what capabilities those are involved. Now let's just click on broadcast audio video streams and have a closer look into that one. You see now on the sidebar, we have many other functions of the system, and for each of those, we can render such a document. Let's have a look at the context diagram. It's also auto-generated, so nobody has to maintain a droid. And it shows us what goes in and out of the function and what actors are responsible for it. And if you wanted to print it, you can also print it and put it on a wall. Right under the context diagram, you see the inputs and outputs sections, plain text, all generated from the model, all using this custom template. This template is really fully customizable. And we come to traceability part, where we see yet another feature. This traceability view is also generated just by crawling the realization links up and down, although in this case, there's not much up. But let's try to follow one of those links and go down to logical functions. We see now one of the functions that realizes the function we just saw before, and you also see the newly generated context diagram that shows us what actors and what actor functions, or subsystems in this case maybe, are involved in the function of interest. Yeah, Just like that, we could handle any other topic. For example, let's have a look at how we handle data classes, and in this case, aircraft. Also a generated on the fly diagram that explains what the aircraft class is made of, what properties it has, and the same information spelled out in the text. We could do the same also for things related to quality of our models to prioritize of the modeling work. For example, here we use a modeling rules compliance report to hint the modeling team where they have work and what work should be prioritized. And we also try to motivate them with hopefully meaningful recommended actions and reasons why they should do this. And again, everything is customizable. Right, so if you are wondering how to run this stuff with your own model, it's all out there on our GitHub. You can just go there and try it out, follow the README. And yeah, now let's switch over to Capella to Polarion story, where we see Polarion, and it's actually the same model that we synchronize to Polarion. Our synchronization has two stages. We start with model elements of interest. We don't synchronize all the model elements, but only those that we care about, and it's fully customizable. So if you don't care about those, but others, you can also just configure that. And let's have a look at one example. Let's pick one function and see what we got over in Polarion. Basically, all the attributes you have in Capella, you can see here. You can also choose or opt in or out of attributes, like if you don't use them anywhere, don't transfer. And you can also see how diagram objects get over the fence. And we also preserve all the traceability. So if something is shown on a diagram and there is a work item in Polarion, this will be auto-linked and you can basically have the same traceability as in Capella, but in Polarion. But why would we do that? We would bring over the model objects to use them to build our documents, because we can reference them in the documents. They don't need to be in the same project. They could also be referenced from another project. That's what we usually do. And you can compose documents using those objects. So when the model changes, the document updates. But of course, we can go even further, and that's the second stage of synchronization, where we use templates, just like those templates you saw in Model Explorer, to build complete documents in Polarion and keep them up to date with the model. And of course, people can then write review comments right in Polarion on those things. Yeah, so all those things are generated from the model, but in this case, it's a full authority document template. So when I change something in the model, the whole document will be overwritten, or well, only the parts that changed will be overwritten. But if I change something in Polarion within this document, my changes will be lost. However, we also have use cases where we want to co-edit the document. So there are areas that people can edit and areas that the synchronization or templates will take over. And that we call mixed authority mode. And here's a little showcase. You see there is text that belongs to Polarion and also referenced objects. And there is another section that is generated on the fly. So when I change it in the model, it will also get updated here. This is how it works. So next to your model, there are two configuration files, the main sync config that defines what model elements we want to see in Polarion, what attributes we want to see in Polarion, what relationships should be there, and also how they should look like. Like, it comes with defaults, but you can customize everything. And the same applies to documents. That's just another config, document config, and it also tells the engine what documents should be rendered, what templates should be used, what model elements should be used to generate those documents. And there is a folder where you can place your templates that override the defaults. All the stuff you see here is also documented. So if you go to Capella Polarion GitHub repository, you'll find documentation there to explore this thing. Right, we will tell you something about automation.
Yes, exactly. I want to share how to interact with Capella models using our Python library py-capellambse to automate tasks. And for that, I started 2 different sessions in the Collaboration Manager, one Capella session and one Jupyter session. On the right side, you can see the Capella session, where I already preloaded the in-flight entertainment system model and opened a diagram in it. On the left side, you can see Jupyter, where I preloaded a script which loads the in-flight entertainment model. I can now interact with the model and see all available options using autocomplete, for example, list all activities. But I'm specifically interested in one activity that I can also see in Capella on the right side, the broadcast movies activity. Capella MBSE will now print a nice overview over all attributes that the element has, but I can also go to a specific attribute, for example, the summary. And we can see that it's the same summary that we can see in Capella. Let's update the summary in Capella and reload the change in Jupyter, and we can see that the summary has been updated. Another nice feature is that we can auto-generate a diagram on the element in question to see the surrounding context. After we've done those changes in Capella, we would usually push to Git or create a commit in team for Capella, which is then synchronized to Git. In Git, we run a few CI/CD pipelines. For example, we generate a model batch, we update the diagram cache, and we trigger Capella to Polarion, what Viktor already showed. To see the model complexity batch in the diagram cache, we have to go back to the Collaboration Manager into the in-flight entertainment project. On the model card, you can see the model complexity batch as a nice overview. And you can directly access diagrams without starting Capella itself in the browser. So now we will play the video that Julius has prepared for us about the project training mode and the hands-on experience for project teams.
All right, let's talk about hands-on experience for project teams and how we try to approach that topic. You might remember the slide from the start of the presentation. As we are launching and preparing a whole range of projects, including the pilot and development project and eventually our full-scale rollouts, we have team members joining with different levels of experience in our tools and methods. So one of our main challenges is onboarding and training a large number of these project engineers as quick and as good as possible. And this training isn't just about our tools like Capella, it's also about our methodologies, like our MBSE approach, which defines how to build models in Capella and how to create the project deliverables we actually need. A good example for this would be a work instruction on preparing a Capella model so it can automatically generate the right interface control documents. All of this is really important because Capella is our main MBSE tool right now. And to produce the high quality project outcomes, we need our models to be consistent in a high quality, and we need to use our methods efficiently. So let's take a look at our current training approach and the challenges that come with it. So usually we train people in the classic classroom style, either in person or in a web meeting where a trainer presents the material and then the learners do some predefined exercises. But we found several issues with this approach. First, it's time and resource intensive for both the trainers and the learners. And to give you an idea, we typically train about 10 people in a 1-day Capella basic training. So you could imagine how much time and resources this takes when we're trying to train a lot of new projects. Second, there is the issue of a fixed learning pace, and this is a big one for the learning experience. We all know that everyone learns differently and at their own pace. And everyone needs to go over different topics again or repeat different exercises to fully understand it. But with our current setup, the schedule is set, so learners have to commit to a full day of training at a one-size-fits-all pace. And finally, scaling. It's not impossible to roll this type of training out to a large organization, but it's definitely not efficient. And sometimes I would say it's even ineffective. So a lot of challenges, but to overcome these challenges and to scale up our approach, we've developed a solution. And it is a new training mode for Capella. It's on-demand, scalable, self-paced, and built on open source platforms. It includes interactive content, hands-on exercises, real-time feedback, and lets people learn at their own speed. So let's take a look at how we put all of this together. First, the training mode is fully integrated into our Capella Collab Manager, which we talked about earlier, so I won't go into details here again. You see the training mode as a tile on the interface right next to the other projects and trainings. From the Collab Manager, you can start the training anywhere, right in your browser, no local installation required. And now here is where it's getting really exciting. On the right side of the slide, you can see the user interface we've implemented. We designed a split screen view. On the left, you have the training material, and on the right, you have the Capella tool itself. On the left, the training material is presented in a markup format with text, images, and so on. Each section includes exercises so the user can put the concepts into practice. And each user gets a fresh copy of a Capella model for these exercises, of course. And here is where it's getting really interesting again. The exercises are directly linked to the Capella tool, and we've set up predefined test cases for exercises using Python and our open source REST API plugin for Capella to see if the user actually completed the task correctly. For example, if a user needs to create a logical component in a specific diagram, the system will check if they actually did it. If there are any issues, the user gets hints to help them along. And if the user makes mistakes or accidentally messes up the whole model, they'll also get notification to guide them back on track. We built all of this using a free and open source toolchain with React, Vite, and TypeScript for the training material, and of course, Capella for the MBSE modeling tool. Now, let's have a quick walkthrough to see how it looks in reality. Let's begin our demo in the Capella Collab Manager, which is the central hub for accessing all of our on-demand training resources. Here you will find every training module organized and ready to start. In this training session, we are explaining how to use the property value management add-on in Capella, or in short, PVMT. And in this overview, you can see the details of our PVMT training. This page informs you about the topic of the training, outlines the goals, and so on. Let's start the session. Since I am currently working on the content, I can run it locally to have faster iterations. For the introduction, we have implemented a short video explaining the objectives of the training, what to expect, and so on. Navigating through the training lessons is really simple using the navigation bar at the top. You can switch between the sections and keep track of where you are in the lesson. For this training, we are using a smart home example, which is a relatable and practical scenario. Let's quickly jump into one of the chapters. And in this section, it is explained how to assign a custom property to a physical component. As you can see, as soon as we're selecting a lesson which has exercises, the Capella tool is automatically shown in split screen view, and a fresh copy of the corresponding Capella model is automatically loaded. But of course, the individual progress will be saved. Within all of our chapters, you will find a mix of text, images, and exercises. And let's now tackle a hands-on exercise where we need to extend the physical architecture in our Capella model. And our task is to create a physical component named radio in the dining room and assign a specific type of devices to it. And let's now do it. I will first of all create the physical component in the dining room, I need to save my model. And as you can see, it automatically recognizes that we have created this one. I will now intentionally make a mistake, name it, for example, audio. Also need to save it. And as you can see, no, it's not the right name. We need to rename it. I will do it quickly and save it again. And you will see that the progress is automatically recognized here. Our last step is to change the type here. I will select devices, and I will also need to select the audio device here. Pretty simple. You see the color changes because we use the PVMT add-on. Save our model, and finally done, we have accomplished our exercise. In addition to the exercises, we have also implemented knowledge checks in the form of a quiz. And here you see an example of a quiz where we need to answer the question for which layers you can apply the PVMT add-on. And of course, it's for all layers. And you see the answer is correct. Looking ahead, we have some upcoming features we plan to implement. These include training or certification path to efficiently recognize expertise, and of course, more training courses to efficiently onboard our project engineers. We just explored the PVMT topic, which is one of the many modules we plan to develop in our training strategy. PVMT is therefore just a single module within one of our clusters, because we believe that offering many smaller but more focused trainings is more practical than providing a few larger ones. And this approach shall ensure that the participants can access the specific knowledge they need when they actually need it. To achieve this, we have organized our trainings into major clusters, including, for example, modeling for specification and projects, or modeling for simulation, test, and integration support. And of course, there are many more topics to be added. Our training approach allows us to customize individual training paths based on individual roles, objectives, and also interests. Now, think back to our initial challenge. We need to onboard and train a large number of project engineers due to the numerous projects we start. We need to ensure that we have a high quality but efficient training. With our on-demand training approach, we can now better support our pilot and development projects and overcome the challenges with the classical classroom trainings. Thank you very much for your attention, and I will now hand it back again to my colleagues.
Right, so what's next? Basically, feel free to visit our GitHub page. The link is right there. Try those tools on your own, and most of the things we do open source, so everybody can benefit from that. But we also hope to see people contributing back and working together on those projects to make systems engineering more useful for more and more projects, more and more people.
Thanks a lot for your attention and listening to our presentation. We would now also like to get in touch with you because we want to understand your needs, your challenges. Maybe you already use our tools, or if you don't, we would like to know why you don't use them and what challenges we could still solve or implement. So here are our LinkedIn profiles. You can just scan the QR code to get in touch. Feel free to reach out. And now we are open to questions.
Yeah, so we are collecting the first question. So thanks very much for your presentation. So as I think I agree with him, so it's one of the most impressive MBSE workflow I've seen with Capella, of course. So how long did it take to establish, and how large of the team is required to manage the custom infrastructure?
We started early in 2019, and it wasn't Capella that we started with. We were actually back in the SysML times, SysML1 times. So Capella was a small pilot, and it started with just a few intern students. But over time, the team has grown a bit, and we also got some outside supporters. So actually, big thanks to the team, but also to our GitHub contributors. that help us to drive this forward.
That's great. Thank you. So again, an impressive suite of tool. Of course, Samuel, I know him. He's an Obeo, so we know that it's very tricky for measuring software maintenance. So, what about the training session? So I suppose the content has to evolve very regularly, doesn't it? So how you manage the training material? So we saw the presentation.
Yeah, this is a pretty new thing for us too. We're just starting to pilot that. But most of the things we learn from the classroom trainings. And we also learn it from the coaching sessions that we have with our end users and key users in the projects. So, if you have to repeat the same pitch a few times, kind of feels, maybe we should make a training out of it. And I think we see more and more work in training development for the next year for our methods team.
Great. So thank you for the answer. One
By
last.
the way, sorry,
please.
on
Please,
that one,
Viktor.
one note. If you
please.
if you like to contribute and work together on public and open trainings, we will be super happy to hear you and do that.
One last question where I don't think we can go in details, but if you want to try to give an answer, or probably you can then discuss with Jan in the future. So it's a little bit more technical. So if you would like to create a Capella model with diagrams programmatically in the Python script and visualize these diagrams, can I do it with a py-capellambse MBSE library you provided, or without anything installed? So you show all the reading, but can you generate those?
Yeah, in short, yes, you can. You will need a few more Python libraries, and if you like diagrams to be laid out nicely, you will also need ElkJS, but provisioning is fully managed. If you are on macOS or Linux, you will not have any trouble. If you are a Windows user, you may want to go into WSL, but otherwise, yes, you can. The library can create and make commits to the models.
Great. Thank you for the answer. Let me see if there are other questions. Let me show it to you. So great presentation. What are the future improvements? So what you are planning to do for the future on this topic?
Oh, where do we start? First of all, we try to be open about this. So if you actually check out the GitHub and the issues or project boards, you'll see what's next. But in a nutshell, training is a big thing for us. And of course, everybody is curious about SysML2 and LLM integrations. We are also curious about that. Let me say no more.
How many active users you have in Capella? Of course, you have a fixed number of license, but do you have an idea how many people are currently using Capella in your organization?
Yes,
We
right
have actually 2 environments.
Yeah, right now we have 2 environments. We have one environment which is for Deutsche Bahn internally, and we have another environment for Europe's Rail. In the Deutsche Bahn environment, we have roughly 400 registered users, and in the Europe's Rail environment, we have around 200 registered users. We have to mention that certainly with the browser-based access, we make Capella a lot more accessible to other groups as well. So you can just register and get started. But we also have quite a large number of active users.
Thank you very much again.
Thank you.